We have these three equations given in form of y equal to ax minus 5, x plus 6, 3x plus b. In the xy plane, the straight line graph of these three equations above each contain a point PR. That means these three lines are intersecting at one particular point. Each contains a point PR. If a and b are constant, then what is the value of b? So we need to find out the y-intercept of this third line. So let me quickly do one thing. Let me just try to make the graph of these three lines as much as it is possible, because we know the second line completely for sure. So we can quickly draw the graph here. We see that the y-intercept is 6, y equal to mx plus c, so m is equal to 1, and the y-intercept is 6, so we have a point here which is 0, 6, and m is equal to 1, that means the slope is 1. So the line, this line will actually look like a line making a 45 degrees, and the figure will be somewhat similar to what I've drawn here. Right? Let's assume that this angle is 45 degrees, so that the slope is 1, and this is this second number line. Now the third line is saying that here we have 3x plus b. So we don't know what is the y-intercept here, but we know that the slope is equal to 3. So the line with slope 3 will have a line such as, I'm just symbolically drawing a line here. So we will have a line of slope 3 such as this. So it can be anywhere. That means the same line can be shifted anywhere to the left, and it will always be a line with slope 3. But the y-intercept is unknown, therefore we are not just marking anything right here. The third is ax minus 5. That means this is the line which has negative 5 y-intercept. So let me just draw this. If we have 0, 6 there, then we have a point which has negative 5 y-intercept right here. It will be 0, negative 5, and the slope is unknown here, so a line is cutting this purple line in this way. And we know that there is a line, that there is a point that is available on all three lines. So this was the graphical understanding, but here, since we need to answer the question, so I'm going to go an easier way instead. What I'm doing is that if there is any line that passes through any point, then the point always satisfies the equation of that particular graph. So I can substitute x equal to p and y equal to r in all these three equations. So let me just quickly do that. According to the first equation, we get r is equal to a times p minus 5. The second equation gives us r is equal to p plus 6, and the third gives us r is equal to 3 times of p plus b. Now I'm going to simplify them if that's possible. So I'm just going to solve the second and third line first. So I see that p plus 6 is equal to 3p plus b. That gives me 2p is equal to 6 minus b. So p is equal to 6 minus b divided by 2. That's one of the equations that we have got here. Also, if I equate these two lines, we can say that ap minus 5 is going to be equal to p plus 6, and this further gives us that p a minus 1 is equal to 11, so p is equal to 11 divided by a minus 1. So now we see that it's all dependent on the values of p and a. B is dependent on p, which we need to find out, and p is dependent on a. So if we knew any one of these values, we can answer the question. The first statement says a is equal to 2. So if a is equal to 2, we can find that value of p will be equal to 11 over 2 minus 1, that is 11. And for p equal to 11, we can substitute 11 here. So we can say 22 is equal to 6 minus b. That means b is equal to 6 minus 22, which is equal to negative 16, which means the first statement alone is sufficient to answer the question. Now, the second is r is equal to 17. So let's quickly start working with it. If r is equal to 17, then we can substitute the value of r right here. So we say 17 is equal to p plus 6, that means p is equal to 11. And now that we know that p is equal to 11, we can substitute the value of p once again over here, and we can find out the value of b, which will be equal to minus 16 once again. That means second statement alone as well is sufficient. So it was simplification of these three equations algebraically rather than the graphical representation. However, here we say that the answer is option D. The first approach, that was the graphical approach, was not as good because we didn't know the y-intercept of the third line and the slope of the first line. So we just used the algebraic approach, substituted the values from one statement to the other, and then equated them. Thank you so much.